General principle of titrimetric analysis. A titrimetric method of analysis is based on a Planck chemical reaction, A-TT products, where a molecule of analyte A react with T molecules of reagent capital T, which is called titrant. A reagent solution of precisely known concentration that is added during the titration. Titron, a substance whose concentration is to be determined by titration. Indicator, a reagent that indicates the state of level of the something. Endpoint, the point at which the color of the solution changes completely due to formation of product due to the addition of indicator. It is also called theoretical or stoichiometric endpoint. Estimated calculation. The calculation involved are called stoichiometric. The stoichiometric calculations are based on the mole and mass relation between the elements and compounds as expressed by the chemical equation. Standardization, the process by which the concentration of a solution is accurately determined, is known as standardization. Terms involved in titrimetric analysis. Standard solution. The solution of known concentration used in titration is known as standard solution. Normal solution. The solution containing 1 gram equivalent weight of substance dissolved in 1 liter of volume is called normal solution and represented by 2 normal solution. Decinormal solution. A solution containing 1/10 gram equivalent mass of a substance present in 1 liter of its solution is called decinormal solution. Semi-normal solution. The semi-normal solution is the solution in which 0.5 gram equivalent of the solute is dissolved in 1 liter of the solution and express n by 2 or 0.5 normal solution. Centinormal solution, a number of gram of 100 gram equivalent dissolved per liter or 0.01 normal. Types of standard solution. Primary standard solution. It is the standard solution which is represented by dissolving calculated mass of substance from certain volume of solution and directly used to determine the concentration of unknown solution, which require equal to NEB with housing. Secondary solution, it is the standard solution, the concentration of which is first determined with the help of primary standard solution and then used to determine the concentration of unknown solution S1B1 equal to S2B2. Aliquots, a portion of sample withdrawn from the volumetric flask with pipette is called aliquot. Each smaller component of the sample is referred to as the aliquot, and it has the same properties as the original sample, but only difference is in quantity. Redox titration. Titration involving change in oxidation number or transfer of electrons among the reacting substances are called redox titration. Requirements of a redox titration. The reaction should proceed rapidly so that the titration can be performed within the reasonable time. A definite known equivalence point should exist between the oxidant and reductant. A suitable technique should be available for the detection of endpoint to half reaction for any redox titration system should be in equilibrium at all points after the start of titration so that reduction potential for the half cell remain identical at all points. Redox indicator, a compound which shows different color in the oxidized in reduced form. Types of redox indicator. Self-indicator, a colored substance may act as its own indicator, example, potassium permanganate. A specific indicator. Specific indicator is a substance who reacts in a specific manner with one of the reagent in a titration to give the color. Example, stars produce a deep blue color with the iodine and thiocyanide ion which produces red colors with ferrous ions. External or spot test indicator, when the chemical species is externally added to act as an indicator, is called external. Is called external indicator. Example: potassium ferrocyanide acts as external indicator. Ammonium sulfate acts with the potassium dichromate. Internal indicator, true redox indicator, an indicator which itself undergoes oxidation reaction, may be used and shows different color, oxidized and reduced form. Example: potassium permanganate. Characteristic required for redox indicator or ideal redox indicator should mark the sudden change in the oxidation potential in the neighborhood of the equivalence point. Redox indicators are those having the oxidation potential intermediate between that of the solution titrated and titron, and which exhibits sharp in point. Example: 110 phenone, toluene, iron, second iron heroine. The oxidation and reduction should be reversible and quick. Redox indicators should change color over a particular range. For a sharp color change at the endpoint, indicator oxidation potential should differ about at least 0.15 volt from the reaction.